participants join, and because Tuhami has just sent me an email, he has a technical problem with Dorothée, and they will join in 5 minutes. So hopefully we'll be starting by then. Thank you. Join, I can start by reviewing what we have seen yesterday and answer any questions. So before I review what we have seen, do you have any questions from what we have seen yesterday in terms of the rationale of CGEs, the micro tools, the macro tools, the social accounting matrix, the difference between forecasting and simulations? Any questions on these points?
Hi, everybody. So it's me, Esma. I would like to have a little bit more explanation about the SAM, if it's possible.
So perhaps in terms of the SAM, let me show you a concrete example because we will be seeing this today. Yes, here it is. So the social accounting matrix is a national accounting matrix that shows the different interactions between different economic agents that we have. So in order to read a social accounting matrix, we read it the following way. Just I will activate the annotation. Yes. So what the column pays to the row. Okay. So this is why For instance, if I look at what the commodities here they pay to the institutions that we have here, it means that, for instance, the indirect tax, in the sense that those who sell the commodities, right, will have to pay to the government the taxes. So that's the way we read the SAM. So the SAM combines different economic flows at the macro level for different institutions. Institutions, I mean households, government, firms, and so on, for different economic activities that produce, for different commodities that are consumed, and all this with respect to the rest of the world, right? So to clarify the way we read the SAM, here we have the rest of the world, right? So the rest of the world is going to buy our own exports, which means that the rest of the world will buy the exports from the market. That's why the rest of the world is going to pay to commodities the amount of exports. Okay? Another example, the same goods that are sold on the market, who will buy these goods? Either the economic activities that will pay the price of intermediate inputs, or households that will pay the price of consumption, right? And the government that will also pay for government consumption. So each column pays to the row. That's the way we read. So first, it's a document that summarizes the different economic flows at the macro level. Second, it shows each cell shows the payment from the column to the row. Third, the social accounting matrix should be in perfect equilibrium, which means that the sum of each row must be equal to the sum of each column. And that's why the rationale behind this is that what we spend in general is equal to our total revenues. So total expenditure is equal to total revenues. Okay? And that's why if there is a difference of even just 1 cent between the row and the column, the model will not be able to converge. So that's why we have to make sure that the social accounting matrix that we rely on is in perfect equilibrium. Fourth and last point, as Tuhami said yesterday, the level of aggregation or disaggregation of a social accounting matrix depends really on our research question. So I can have one labor and one capital. I can have 10 types of labor and one capital. I can have 10 activities. I can have 100 activities. All this depends on my research question. Okay? So is that clear?
Yes, thank you very much. I would just want to have clarification. Why do we have activity and commodity? Like, and
Yes.
then why do we have factors and households? Since usually we consider like work coming from the households. So you see my point.
Yes. So the difference
Yes.
between activities and commodities is basically the difference between the activity that produces the good and the good itself that is sold on the market. Because if you remember, we said that in a general equilibrium framework, we have to take into consideration the factors of production market, the goods market, the capital market, and so on. So I have to model all these markets. So the activities are basically those who produce. So it's for instance, I have a sector called textile that will combine labor with capital with intermediate inputs to produce textile. But then once the textile is produced, it will go to the market in order to be sold, right? Who will provide these goods that will be sold? It's the commodity account. So the commodity account includes the final goods that will be consumed by household, by firms, by the government, and by the rest of the world. So in other terms, the commodities that are produced here will be bought by economic activities in the form of intermediate inputs, by household in terms of consumption, and by the rest of the world in terms of exports. And here institutions include firms and government that will buy also final goods, because the government needs also to buy some goods. So that's the difference between commodity and activity. The difference between factors and institutions or households, because household actually is part of the institution. So factors are basically labor and capital, and they are combined with intermediate inputs to produce. So in other words, household, they will give they will provide, or they will supply the labor market with their own services. That's why here you have factor income, right? So once on the factors market, they will supply their own factors of production. So they will be paid in terms of their wage, and that's why the factor income is part of the revenues of institutions. And here, institutions is basically, as I said, includes household, government, firms, and the general institutions of the economy. Okay. Why
Households is the next row, isn't it?
Yeah, but what I said is that we can consider that households are part of the institutions of the economy. So, briefly, institutions in national accounts in general, based on the system of national accounts of 2008, and then in its revision later in 2023, we have 6 institutions in the national accounts. We have private households, we have the government, we have firms, financial firms, non-financial firms, non-profit organizations, and the rest of the world. Those are the 6 institutions that we have in the system of national accounts. In CGE models, or in social accounting matrices in general, institutions that we include in the social accounting matrix are 4. We have the government, we have firms, we have households, and we have the rest of the world. So depending on the schematic presentation that we use, in some cases we combine households under institutions, household and rest of the world under institutions. In some cases we divide them. So, but in all cases, those are the institutions that we have. And the idea is that we want to distinguish between what each household provide as a factor of production, and then gets the wage that will be spent on the commodities. And the commodities will be produced by activities. Is that clear?
Perfectly. Thank you very much.
Okay. Rabia?
Yes, on the same topic about the SAM, social accounting matrices. It's not 100% related to what has been explained yesterday, but I have a few questions. First, about GAMS. Can we use the Python package PyGAMS to do the CGE modeling? That's the first question. The second one is about SAM. I wonder if there is a resources that would explain in details how to compile the social accounting matrices. I know that knowledge in national account is needed, but many resources or exercises that I found online only explain how to do aggregate social accounting matrices, does not delve into details, nor, as you mentioned, both the sum of revenues and sum of expenditure needs to be equal. So there is a cross-entropy method in GAMS to make this equilibrium. So I wonder if there is any resources, good resources, that would cover all these everything about SAM to build a big SAM.
Okay.
Not only a simple one.
Okay, thank you. But before responding, Dorothée and Tohem, I think you joined. Can you? Yes, great.
Very sorry for the delay, but technical problem.
No problem. So I just took the opportunity to answer some questions for yesterday's session, and we had a question on the social accounting matrix. So I responded to the question of Asma on social accounting matrix. And then now Rabia was asking a question about a package that can be used from Python in order to balance the matrix. But I can't answer this question because I have never used Python. So I don't know if Tuhemi and Dorothée, you can answer this question.
There is a link between GAMS and Python, but I am not sure that Python can do it. You have to use a process. You have to code to balance a sum directly from GAMS, not from Python. It's not. I don't know how but there is a link between the two. If you have knowledge on Python, you can do it. But I am sure we can do it in GAMS only.
Same for me. I have never used Python, so I don't know. On the second question, in terms of the resources to construct, to build, and to balance the social accounting matrix, I don't know, Tuhemi, if you want to answer. To my knowledge, I know two main sources that are very useful and that might be very relevant. The first one is the documentation provided by IFPRI. It's very detailed and it helps you explain how to gather the different sources of information. The other one is also PEP network. Those are the two sources that in general I rely on. But in general, it's good to start with a short version of the social accounting matrix that where you make sure that is balanced and then you detail it. And then perhaps also Tuhemi or Dorothée can give other sources.
You can use the, I am using the PEP resources. We have developed many approaches in a PEP network to go to PEPNet, and you have many resources for a CGE, in particular for a some accounting. There is a document, and there is the references on the United Nations references. Yes.
Great. So I will stop here, and now over to you, Dorothée.
Okay, thank you. Then I will share. And you receive again. Sorry for the delay. We don't like that, but and here. Then I think that here. Ramesh sent a document for the trainees this morning. You have a short version of what I will present now, and I will complete also on the screen directly. It's why I let some white space for complete during the session. Then if I come back on what we did tomorrow, we make a review of micro foundation, and it was, I imagine, to refresh some point, but it was relatively obvious for you. Then today we have what we saw yesterday in mind, and we go behind with a model. Then we will see first model. You will have in the documentation two models. One is the name is basic. I will skip this model because it's very basic. Then you can take a look when you will have the documentation. But I will begin today with a model. Then now with what we saw yesterday, we will construct or have an idea of a real model. We begin with a simple. It's not basic, it's simple, but it's the topics of this first session today. Then we have a model a closed economy model. Then what that means, we don't have exchange, and this change with the presentation of Shahir after this one. Then now in this simple model, we have a closed economy and no government. Then we don't have taxes and rest of the world in this first model. We are on perfect competition. That means that the price, the agent are a price taker, and we have only one household and a representative household. And the next week you will see that we can have more than one household in the microsimulation session. And we also have only two branches in this model. It's the difference between this one and the basic that I mentioned previously. Here we have two branches, goods and services. Then it's the framework of this simple model. In this model also, we have endowments that are exogenous. We will see later what that means. It's supply labor and supply capital. And we assume also, and that it's very important in this model because we can relax this assumption, we assume that the labor and the capital are two factors that are mobile. Then I will insist on that during the presentation. But for this model, we assume that workers can work on the both model, goods and services, and the capital is also mobile. Of course, it's a huge assumption here, but it's to understand the principle. Then I have here, I have here a figure. It's from PEP network. We mentioned that you have a lot of documentation on their website, and it's a graphic, schematic representation of the model that I am presenting. Then if we begin here, we have agent. It's the household, the representative household. I think it's okay, then we are here. And the household demand for goods and service. That means that they have demand for the two products that we have in this model. And since, as I mentioned previously, we have two sectors. Then the demand for goods and service. Then we have also two markets. Then a market for goods and a market for services. When we aggregate these goods and service market, we have the national production. And the national production comes from two sectors, as I mentioned in the beginning of my presentation. And we have demand to produce this national production. We have demand for factors of production that are, as I mentioned also, labor and capital. Then we have market factors of production market, and we have output or goods and market in this economy. Then it's a very simple representation of the economy that we want to model in this simple version. Here it's another representation of this economy. It's again very simple. It's like what we have in our introduction to micro book. Then here you have 4 quadrants. The first one, yes, it's this one. So yeah, you are the first one. You are in the plan of the goods that are produced in the economy. In the following, for the notation, I precise that I don't change the graphic produced by PEP network. Then for the following notation, these X become a Y. Then we have two products, services and goods. And here you have the production possibility frontier. Then it's the considering factors, the repartition of the production between the two goods that we have in the economics. In the fourth quadrant, I will go like that. Then in the fourth quadrant, we have the function, the market of goods. Here it's a good market. Then we produce Y goods with labor, and for a level of capital that we consider fixed in this representation, since we are in the two-dimension graph. Then for a level of capital in this sector with a level of labor, we can produce with a function f that we precise the form after. We can produce the goods Y BNS. Here in the third quadrant, we have the labor supply. The hypothesis, the assumption that I mentioned previously is that the labor is mobile. Then we can go from one market to another, one sector to another, with the same wage. Then the capital, the labor is mobile. The wage on this market is W for the both sectors. Then the mobility is represented by this linear.
Can you write it LD BS plus LD equal R?
He is always like that.
Yes.
I
just to interrupt.
Interrupt me. Then don't worry. What do you want? L
S equal
LD B NS plus LD service.
This is the.
Okay. This is the relation that you have here. Okay. And the last quadrant is the same than this one. It was for goods here, and here we are in the sector of services. Then with a function production, a production function, we produce Y services with labor demand for this good, and for a level of capital, ceteris paribus, a level of capital. Then here you have a representation of the model that I am presenting now. There is some question? No? Okay, we continue. No, I need my two fingers. Here. Then, here we are, we see the same model function that we saw yesterday. We have a Cobb-Douglas. We decide to have a Cobb-Douglas technology with a productive factor, demand of capital, labor demand, and we have a profit function. Then PY for each sector, I is the sector, services or goods. Then you have two functions of production. Here you have two equations. I insist on that because now you have to think that in your model, you are the number. Yesterday we mentioned that you have to have in mind the number of equations and the number of variables. Then when you are you have two sectors, we in this the function production, and we have by consequence we have two functions of production. Then you have Douglas technology. We have two profit. The profit is PY, the revenue coming from the sale of the product Y. You have the cost function here. Then W, demand of labor, minus return capital return multiplied by the demand of capital in each sector. Again, you have the index here that is important. We don't have in this on W and R because we make the assumption that the capital and the labor are perfectly mobile. Then there is no difference in the price of capital and labor in this economy. You stop me if there is something not clear. And my English is not better than this of Tuami. Then don't hesitate to interrupt me. Then here, there is no question. Here you have the first order condition that we developed yesterday. We maximize the profit under the production function, considering the technology. And we find here the demand of labor and the demand of capital, but for each sector. And here again, we have two labor demand and we have two capital demand in this model because we have two sectors. Okay, then I think that yesterday we explained, we sufficiently explained the demand, the form of demand, and I pass on that. But you remember that it's the solution of the maximization program of the profit. And we have also, this equation is also important. We have the consistency of the model imply that we have the revenue of the production, then PY, PI, YI, equal the cost, the value of the cost of this production. Okay, I think I didn't omit something. It's okay for this part? Okay. And now we look for the representative household problem. Then we have, by definition, the income of the household. Here we don't have in this because we have only one household, but you can imagine that we can add an H, for example, for household in more consequent model, such as this one that you will see on Thursday next week. Then here we have no index. We have the income of the household is equal. I omit to mention also that in this model, it's important here, all the production is consumed by the household. That means that we don't have saving in this model. It's why we can write this equation. We have the income of the household equal to the the salary, the wage, the value of his labor, then W multiplied by his supply labor, plus the return of the capital in the both sector. Then we cannot, as we have the assumption of the mobility between sectors in terms of capital, we can write this equation with R multiplied by Ks. If we don't have the mobility between sectors, we will have, for example, a high here, because each sector will have a price, and also we have to make the distinction between the market of goods and the market of services. Okay, but here, as we have the mobility assumption, we can write this equation like that. Okay, and it's a definition. In terms of preference, we assume that this household has a utility function that is characterized by Douglas again. I think we discussed about that yesterday, then I pass very quickly. And the optimization problem of this household is, of course, to maximize this utility under constraint and under the budget constraint that we can write like that. Then the household consume all his income between the two goods and services in this model. Okay, then the program of the optimization problem of this household is this one. I think there is nothing very complicated to understand here. And as we see yesterday, with the Douglas, the consumption is the fixed part of the income. And we have the income, you see, here. And here you have the Marshallian demand for that are the solution. And we have two goods, and the household asks for goods and services with this in terms of part of the income. Okay for that? No question? It's too simple. It's why I don't present the basic model. And now we have the production, and we have also the part of household. Then we look for the equilibrium between the both the production and consumption. Then we have the market clearing condition. Here we have, in terms of goods, then we have supply equal demand on the both market. Then what is produced is equal to what is consumed by the representative household, and we have that on each market. And that's why we have here two conditions of equilibrium. The last two is the equilibrium on the factor production market. We have labor and capital. Then labor supply, supplied by the household, is the summation of the demand on the goods market and service market. It's the line, yes, not the in my previous graphics, it was the I don't know, the line that we have in the quadrant left below. And for the capital, we have also the same condition, since we assume that the capital is perfectly mobile. Okay, then we have 4 equilibrium conditions here. It's okay? Ah, il y a une main. Yes. Ibtisam.
Yeah, do you hear me?
Yes.
Perfect. This is really clear. I appreciate it. I just have one question. Are we assuming that there is a zero stock building? Because your demand equals supply, so we're assuming kind of there is no any storage or inventory. There is no remaining supply at all. It's fully demanded, so there is a zero stock building.
Yes, it's a good question. No, in this model, we assume there is no investment, no saving, nothing. All this product is consumed by the household. It's a very simple model. Okay, but we have to begin with that to understand how we construct the model, and after you can add or relax some hypotheses. Okay.
Clear, fair. Thank you.
Stop me if you have a question. Okay, then here. Elle est là, je vais aller là. Allez. And here is the same figure than previously, and we see that that it's the same plan with here. It's Y and Y, I mentioned previously. Then you have here we had the utility function, and we have the budget constraint, and at the equilibrium we will have the equilibrium will be this point. That means that the price, the point, the tangent point of the on the frontier of production will be the same of the solution between the budgetary constraint and the utility function. Then the equilibrium is here, and after that we can determine the here it's the production of the goods on the goods sector, the production on the goods sector. To have this production, we need this labor demand, and we have, if we use this labor demand for the production of the goods, we will use this quantity of labor demand on the market of services, and because we have this condition, and considering this labor demand, we will produce this this quantity of services. Then here you have the initial optimal solution of the model. Okay, for a level of capital again here, because I have only 2 dimensions. Okay, then it's the principle behind the model that I present. But now we see yesterday that we need to have the same number of equations than the same number of variables. Okay, to have this solution, I don't mention that maybe I have a problem. The system is not square. As we saw yesterday, we need to have this condition to find the solution that I only mentioned is the solution, the initial optimal solution of this model. It's not only this point, because all the quantity on this graphic is important. Okay, then to pass from the equation to this solution, I have to work a little bit. It's not finished to buckle the model. Then I come here. Then the Walras law. Yes, I don't know. No, before that, I will to well understand the Walras law. I come back. I'm sorry. Here, the system that I present, if I look the number of variables and equation, I see that I have two products, goods and services. I have two labor demand, two capital demand. I have two price for the goods and one for the service. I have one wage, since I have the mobility between the two sectors, and I have one here, one return of capital also. I have two goods consumed by household, the income of household, the utility of household, the supply capital produced given by the household, and the labor supply also. Then if I count the number of variables that I have in the this model, I have 2, 4, 6, 8, 9, 10, 12, 13, 14, 15, 16. It's the number is good here. Then I have 16 variables in the model. Okay. And now I have to verify how much I have of equation to see if the system is square to obtain the solution. And I will write very quickly here the equation to remember in the model. We have two here with he, y, or I, two production function, and I have two. I don't write all the equation, but I have two demand of factors. Then on the production side here, I have 4 equations. No, 6, sorry. 6 equations, 2, 2, and 2, because I have 2 sectors. Then 6 equations here. For the household, I have the, then you see here it's for production, and here it's for the household. I have the revenue, I have the income, I have the utility of the household, and I have the boss B and C, the boss goods that the household consume, B and C, and C service. And for the household, I have 4 equations. Then between the production and the household, between both, I have already 10 equations. And I have 4 equilibrium equations. On the goods market, equals CI equals and it's 2 equilibrium equation here. And I have also the equation on the labor market and the equation on the capital market. That are the sum of all the here from the then here I have 4 equations. Then if I count, I have 40 equations in the system. And if you remember, we have 60 variables. Then my system is not square. Then if I go to GAMS and I write all this system, I will have a problem. And then I can think that I have only 2 equations. Then these variables, I can fix some variables here in these 16. I can fix 2 of them, and you see that we fixed the supply, supply capital and supply labor. And we will have 14 variables and 14 equations. But then here we can think that we have a square system. But if we look the equation here, it's why I have, oops, I'm sorry. No. Il y a les 12. Sorry. Here we discuss about the variation model, and it's one point very important in this model. As I mentioned, I have 14 equations and 14 variables, but if when I fixed 2 of them, but the point is that in this model we can show that the Walras law can be applied, is applied. Then, and here in this sentence, it's to remember the Walras law. If an economy with n markets, in an economy with n markets, if agents respect their budget constraints and n-1 markets clear, then the last one clears as well. That means there is a question. Yes, Asma?
Sorry to interrupt, but I think there was one more equation, if I recall correctly, where you had Py equals the income, the factor incomes at the beginning. Py equals W S and plus, yes.
Yes, it's not. It's the same of the income, the income, the household income. R equal W. I remember W LS plus R KS. It's the same of the income, and it's the value of the production is equal to the value of
of factor incomes
in value, and it's the same equation, the income of household and this one. Do you have something to add?
If you add this equation, you add the definition of the income only in the model. It's the same.
It's the same. There is no new information. You can choose to use the equation that you mentioned or the equation of income.
Thank you.
You can choose one of the both, but not the 2, because it's the same equation. Since there is all that is produced is consumed, then it's the revenue for the household. Remember the schema schema at the beginning. All that is produced is consumed, and all the income of the household is used to buy the 2 goods. Then it's the same equation. You can choose one or the other, but not the two. I'm not sure that it's clear.
Perfectly, thank you.
Thank you. Then here, yes, I was on the Walras law. Then here to have, for remember this law that we know very well in economy. Then here we are in this case, and we have n markets. Then we have 4 markets, 2 for factors of production, and 2 markets for goods and services in our case. Then if we have these condition also, if we respect this condition also, we see that the Walras law told us that we need only to have n minus 1 equilibrium, and by this law, the last one will be equilibrate. That means that if we have 4 equilibrium constraints, and you remember we had 4 equilibrium condition, not constraint, condition, then that means that only 3 are useful. The 4th will be true if the household respect is budget constraint. Then that means that we have one equation that is redundant in our system. And you remember we had 14 equations, and now with this law, I told you that we have only 13 independent equations. 1 is redundant. Then I had 16 variables. I fixed 2 variables, labor supply and capital supply, and 2 exogenous variables. But here I know that I have 1 equation, and 1 on 14, that is redundant. Then I have only 13 equations, but I have still 14 variables. Then 13 equations, 14 variables. Then I have another problem. Then the system is still not square, and it's why here we put one. We decide to take one price as exogenous. And we call this price the numéraire. And the numéraire is one price that we fixed. We can choose the value. It's not the convention is to put 1. It's more easy to for the system and to interpret. But we fixed one price and the 2 supply factors supply, capital and labor, and now we have 13 equations and 13 variables. And if I go back, yes, I go back here. Here. These 2 variables are exogenous. And I decide to have I chose BCN, the price of the goods, as a numeraire. If I can't count now the variables, I have 2 goods and services, the production in the economy, labor demand 2, capital demand 2, 1. Yes, it was service, sorry. Then I have only 1 price now. It's no more the I that I have here. It's only for goods, the price of goods. I have still wage, return of capital, consumption, income, and utility. And I have 13 variable, endogenous variable, and 13 equations considering the Walras law. Do you have any question? Then here, yesterday we mentioned the closure. In this model, it's relatively easy to decide which variable are fixed. Then it's why we put supply of capital and labor. But the closure is this discussion about what variables will be exogenous in our model. And when you decide to fix one variable, you decide also the variables that you will use to make the shock or to simulate a policy. And for example, you see here, an example, I can decide to increase the capital. There is something, or the capital increase, and then I can look the impact on this economy, applying a shock on KS that is an exogenous variables. Okay. Then these variables are the policy variables in your model. Okay. No question? I think that I can, see there is no question, I can go.
Dorothée, there is one question. Why we considered one of the two prices as constant and have not considered capital in sectors as constant?
Excuse me, I don't hear very well.
Can you hear me now?
Yes.
There is a question from Samira. Why we considered one of the two prices as constant and have not considered capital in sectors as constant? Why? Why the capital is not constant while the prices are constant?
No.
I think.
Yes. Just to be clear, when we are closing the model, because we have the Walras law, one condition, one of the two equations we have here is redundant. We can prove that one market, one equilibrium condition is redundant. So we have to fix one price or a combination of price to be more precise. So in this model, what we can decide to fix the price of the good one or the price of the good two. This is one or the other solution. We can fix other. We cannot, if we fix the capital for each sectors, this is another story. We have to fix a price. We can fix the return of capital or return to labor, wage or return to labor. Yes. We have to fix one price because as we said yesterday, we have to look for the relative price. This is why we fix one price and not one capital price.
Yes, and if I fix this one, for example,
the order is fixed.
And this one, that means that the order is fixed also. Then it's why I can decide to choose this variable, because if I let this one, the supply, if the supply was not exogenous, I could consider to fix this one, but not for the not in terms of I don't know how to explain. It's another story. But you see, with our hypothesis, if we fix the supply, we fix the capital, we have also, then the capital is fixed, the production is fixed, then nothing happens in the economy. Okay, then it's not it's not possible to fix this variable. Jaya, you have other thing to?
No, perhaps just to add one point, because as Dorothée said, we choose a numeraire in the economy, which will be the price of one of the two goods that we have, and that's why one of the prices is set to be constant, and therefore, given that in general, I mean, it's a short-term model, we can assume that labor supply and capital supply are constant. So that's why, as Dorothée showed here, it's the supply that is assumed to be constant, but the demand will adjust to satisfy the constraint imposed by the supply. Right, Dorothée?
Yes. Yes.
Did we answer to your question, Samira?
Yeah. Yes, thanks.
Okay.
Another thing that I omit is that now the interpretation will be in terms of a relative price. Then the interpretation is considering the price that we chose as numeraire. It's important also to mention that maybe in the simulation, when we will be there, we could insist on that. Okay, because we make an ad hoc choice, then it's the interpretation has to be linked with this ad hoc choice.
Can I add something? One more thing. We at the beginning we assume that capital is mobile. Yeah, that means that we need to follow where it earns the highest returns. We cannot fix capital, right?
Yes.
This is the hypothesis. Yes.
Yes. Yes, it's the you're right with your understanding. I think that you ask for something, but you give the answer. Okay. If we have if we don't have mobile capital, we will have equilibrium on two different markets for capital. It's the difference here. We have only two factors and two market factors for labor and capital. If we have no mobility between the sectors in terms of factor of production, we will have more factors market than it will be the difference here. We don't we can yes, we can, but we will have this condition. If we don't have mobility, we will have KDE, not that, but we will have two conditions on for the demand of capital. We don't have yes, because we have also if we don't have the mobility, we will have also a different price of capital. Then we have to consider the capital as a specific factor of production on each factor in sector, pardon, in each sector. Then the functioning, we have to price, and considering the price, the capital can be in one sector and not in other. Then it's like another market of production factor. Okay. I don't want to develop this model because it's not the model that we have in GAMS, but we know that it's a very very large hypothesis assumption, but it's to understand the process of modeling here. After you can, when you are confident with a small model, you can relax some assumption like that. Okay. Go to the presentation, an introduction to GAMS, but sorry, because I have 3 screens in this class. Okay. Okay. Then I know that we don't have a lot of time. It's an introduction, but I suppose I have a large introduction, but I will go very fast. And if you have some question, you can stop me. But maybe in the GAMS we can come back on some points. Here you will have this presentation. Then I will not. I not present all the slide. When it's a software developed by economists at the World Bank, and modelers use this software because it's very useful. It's a useful software when we have a large and complex and even non-linear, with some difficulty sometimes, model. Then it's why it's a very interesting software, and for modelers, a lot of them use it. Yes, and yesterday is the more and more used because now we have a computer, more efficient computer, but also now GAMS develops some not software, different module to use with large data set, intelligence, artificial intelligence, and data mining, and so on. Then there is new aspect of that we can use with this software. I don't know actually because I didn't use that, but I read that the developers think about the use of artificial intelligence also for this software. We have 2 editors for GAMS. We have GAMS IDE, Integrated Development Environment. It's the first editor that we had with GAMS, but now we use more GAMS Studio. It's an editor, and it's more easy to code in these editors. And if you begin with GAMS, begin with GAMS Studio, because when we used the other one, they told us that they will cut the development of these editors. Then there is a lot of submodule, etc. Some module as interesting, notably to transfer data. I think that you will see some example in the code that we share with you, but at the beginning, it was not easy to transfer data. Sometimes we had to write each information that we have in the matrix in the GAMS. Now it's more easy. Here you have the interface. Here it's IDE editor. Then it's the Windows. Here is the Windows where we write the code, and here is the window with the result of your model. Yes, here we have three main steps when we write a model. The first one is about data. Then we have some word that when it's in world, it's a keyword in the code. Then you cannot choose this word as variables or a parameter, but it's a keyword that you have to use to declare set or parameter and display. You can see the data that you have in the model. For example, if you want to verify if the matrix is well transferred in your model, you can use the display. And if you make some calculus in your model, you can also verify with this command. Then the first is the data, the assignation of value and parameter and variables and parameters at this step. I go back later quickly. The second step is the model, the declaration of the model. Then here you have variables, equation, and model. Yesterday, Tuami told you that you don't begin directly on GAMS. You have to write your equation, see the variables. As I showed in my presentation, you see, I have to know what are the equations, what are the variables, and I have to declare in the model. And finally, I give a name of model. I define my model at this stage. And finally, the third step, is the resolution with the command solve. Solve is the resolution of our model. And I have different means to present the result. Then these three steps are very important. Here you have some rules. As all the software, you have rules. And for example, I don't know in English, point, virgule. I don't know the name of that in English, but at the end of...
Semicolon.
Comment?
Semicolon.
Semicolon, yes. Thank you. And a semicolon, you have to put the semicolon at the end of each line or command. We see that later. GAMS important. GAMS does not distinguish between lowercase and uppercase later. Then don't put the name in lowercase for a good and uppercase for another words. It's not or another element. GAMS doesn't distinguish that. Yes, and avoid accents. but it's for French modelers at this point. Yes, you can add some comments in your program, and it's very useful. If you work with someone, it's useful for the colleagues to see why you developed something, or if you develop a model and you anticipate in 2 years to come back to your model, it's interesting to have a lot of comments. And you have also the line on text, $on-text, and $off text that are very useful also, because it's a mean to have a model and to cut some part of it. So very quickly. Yes. The first thing that we declare in a model is the set. In the model that I present, of course, you have two goods. Then the set here, it's the branch of activity. Here it's for another model, but in the model that I present here, you will have goods and services. Okay, then it's what we have. Then set is a keyword. The index that I have in the model, you can ask some explanation. And here it's not taking account by GAMS. It's not. It's only a comment. And here it's the name of the sectors that you have. Here is the name that you will use in the model, and here it's the comment, the information about each line. But this part is not taken account by the model again, and it's between two empty slash, and you finish with a semicolon, the declaration of this set. Here is for household. Then in our model, we have only one household, and then we don't need to declare a set for household, but we see that
for institutions.
Institution?
Tourism.
Okay, it's yes, economic agent. Then here you have.
Perhaps, Dorothée, just one comment here, because if you remember in the beginning of today's session, someone asked me about the institutions. So here the economic agents that Dorothée is talking about are the institutions, actually: household, enterprise, state, and rest of the world. So that's the concept of institutions in national accounts.
Yes, here you have all the agents of your economy that you find in your matrix, your SAM. And it's here that you will declare all the agents that you have in economics, and you have the rest of the world, government, enterprise, firms, and household. Okay.
Specifically, how we declare a set this.
Yes, I mentioned with that, and with that at the end. Here, you begin the declaration with the slash, and you finish with slash and semicolon. This one is optional. You don't need to add if you don't want, but again, it's interesting for the memory to add some explanation here. Yes, sometimes it's not the case in the model that I present, but sometimes we have variables with a double indices. For example, intermediate consumption, as we saw yesterday or today in the matrix, I imagine. I was not there, but you have two indices. And for that, we have the possibility in GAMS to use an alias. An alias is to say, because intermediate consumption is for the consumption of good 1 in the production of good 2. Then the I and J are the same indices. For GAMS, to explain that it's the same, we use applied and yes. Here I declare the set as previously, then agriculture, industry, services, and non-tradable services. Okay, it's the sector that I have in this economy, and I use the alias because when I want to modelize the intermediate consumption, I declare to GAMS that I and J are the same index. But here I can have agriculture and J can be industry in the model. Okay, then I told to GAMS that it's the same set. The set is I, but I can use as I want. I put some guillemets, I and J differently. Then consumption, for the both consumption that I had in my model, I can put J or I. It's equal, it's equivalent. But when I have variables with a double index, I have to be cautious because I have I and J, and in the model, for example, if I sum on I know that the result will be variables indices by J. Okay, it's a little bit, I know that until you didn't show that in the model, it's not very, evident, but it's a very useful option in GAMS. You have to have in mind that I and J are the same index and are the same set, okay? And I can change the variables. I can have variables I, variables indexes J, or variables index I, or variables index J. Then it's open. It's introduced flexibility in the notation when I write the equation. Then alias, it's a keyword also. It's a very useful in modeling. Qu'est-ce que ça m'a fait?
Perhaps also I just want to link what Dorothée was just saying to the question that we had also in the beginning of today's session, because I think it was Amina who, Asma, I don't remember, who asked me the difference between activities and commodities. So in general, if activities and commodities in the model are the same, in the sense that if I have, for instance, 4 sectors that produce and 4 commodities that are produced, we can use the alias command that Dorothée just mentioned. So that's why in the sum, we have the activities that produce and the commodities that are sold on the market. Over to you, Dorothée, sorry.
No, it's a good point. Then I don't know, Shahir, because here I begin presenting the parameter variables, and I see the times. Maybe we can go to the I don't know, to the
break now.
I don't know. What do you think? Because I don't want to.
Yeah, I think we can break and then continue the GAMS code and the first model. And even if I introduce the first part and then do the code of the open economy next week, this should be fine. So shall we do that?
Yeah, yes, we begin with the GAMS, huh?
Yes. So I mean, you can continue after the break with the introduction to GAMS, then present the code of the model, and then I continue with the open economy model.
Okay, perfect.
Okay, great. So we break now for 15 minutes,
Yes.
and we will start at 4:45 or 4:45 Cairo time.
Okay,
Thank you all, and see you in a while.
thank you.
So let's continue the part on GAMS, and then we start the open economy model after the simple model that Dorothée will present.
Okay, thank you. Excusez-nous, on est sur...
Est-ce que vous nous entendez?
Oui.
Très bien. Alors, je vais partager. Je me suis mise sur mon ordinateur. Voilà. Donc là, we are in the GAMS. Okay. And then we are on IDE. I have a problem with GAMS Studio, then it's why I use the old old platform for GAMS. But when you, I think you had you received the code, and you can use GAMS Studio or GAMS IDE as you want. Then here you have the code of the model that I present. And here, usually when we begin a code, we give a title. The trainees have the software with them. Everyone has the computer with.
In theory, yes. So they receive the code and they're supposed to download GAMS. So
Yes.
Did anyone have any problems downloading the software? So
No.
I think we're good to go.
Okay. If someone has difficulties, tell us, and we can help to have the program with them. Then, as I mentioned, generally we use the title for the model. Then here it's the second model GAMS workshop, and the name closed economy without government, 2 factors in production and 2 sectors. Here it's a title that then we will see this title at the beginning of the output produced by GAMS. And you see also the first line here and this one begin with a star, then that means that it's comment. And generally we separate the section in the program to facilitate the reading of the program. And you have to have in mind that someone can read your program. Then if you want help him or assure you that the reader understand your program and can agree with the result of your program, you have to be very clear on each step of the program. Then here we have sorry. Here we have the different section. I separate the section to put in evidence each part of the code. Then, as I mentioned before the break, here we have a keyword set. Then we declare a set. For here, I keep the sectors of the model that the code was developed by Shahir. I precise, this is not my code. I rearranged the program, but the code is developed by Shahir. Then here we have two sectors, agriculture and industry. And you see in this interface, you have some colors. Then keywords are in bold and in blue and in green with, then you have the name I here, and you begin with the slash, finish with the slash here. And I forgot here, semicolon, I forgot. Then agriculture and industry for the set. And you can see here, I don't use alias because I don't have variables with a double index. Then it's in the fall to put an alias. And if I have other household, for example, qualified, skilled household and skilled household, or rural household, and urban household, I could have also a set for the type of household in the model. The second part is declared by parameters. Then here you have the real parameters of your model. In this model, the simple model that I present, I have only 3 real parameters. I will explain why I mention real parameters. Then A, scale parameter of the production function, alpha, beta. Here and here you see other variables that I declare as parameters. Here, when I do that, it's because the reference situation, the reference at that I have in the matrix, the data that I have in the matrix is the reference data. It's the base data, the data that I know. And the convention is to put the name of the variable, income, consumption, production, capital demand, labor demand, wage, and so on, and to add a O at the end. It's a O for origin, the data at the origin period. Then I have the variables, but in the model, I declare these variables at the reference period as a parameter. Okay, then it's an important fact here that I have to precise. The next step is the calibration step. Yesterday we discussed about that. The calibration is the assignation of the value for each parameter or variables at the reference period. Then here you see we have rho, that is the return of capital. Then rho O equal 1, PO I equal 1, WO equal 1. It's the value, as we explained before we discuss the interpretation of the result will be done in terms of relative price and in terms of variation. Then the first the price, the value that we give to the price is not very important. You can choose other value, but you have to be careful. We will see in the next line why you have to be careful when we assign another value than 1. Here we have the labor demand here for the agricultural sector. Here in this model, as we have a very small model, we don't have a matrix that we need to import in the GAMS. I think that maybe Shahir showed with the dynamic model, but I know that Tuami will show you an example where you import data in GAMS. Here we give the value because we have only a very small number of value in this model. We put the value directly at this here in the model directly. Then we have the demand of labor for the agricultural sector, industry sector, the demand of capital for the both sector again, and here it's value that we put. Here you have something that is very important. You know that in the matrix you have the value of the variables. But when we developed the model, the variables was expressed not in value, but in volume. And in here, when we write this line here, I hope you see well, you see that I use the KO value here, the KO value, and I divide this value by the price of the capital. And it's why I have this expression. And by consequence, KO now is expressed in terms of volume. If I use KO in other equation, the KO will be expressed now in volume and no more in value. Okay, then it's very important, and it's a reason why I mentioned the price that you put here can have an effect of all the value of the value or volume that you deduce. Then here it's a mean, a usual mean to pass from value to volume in the model. You have the same for the labor, and here as the price is equal to 1, you have the price of the production is equal to the price 1 KO is expressed now in volume because the price is equal to 1. Okay, then here you have the value of the production is equal to the cost of the production. And it's one of our equation. And here at this point, you see alpha y then and AI, and you see that it's an expression. And if you look for this expression, it's what Tuami developed yesterday for alpha. It was the elasticity, and we can, because the matrix or the data that I have doesn't precise the value of this parameter, and I have 2 parameters because it's indexed by I, and to find the value of this parameter, I know the return of capital, I know the capital demand, I know the price, and I know the volume of production now. Then, as I know everything in this equation, I can find the value of alpha. Then it's the principle of calibration. And yesterday, someone asked, how do you calibrate? And Tuami answered that you can find in the literature for some parameter, but it's the free parameter, but we can calibrate directly in the model like that the other parameter. And it's important because it's this calibration assure the coherence of your model. Okay, then we make this calibration for alpha, for A, and here we have only the condition, the supply capital equal the sum of demand capital, and the same for labor. You see how in GAMS you make a sum, and you sum on I, the KO I, and you don't have any more indexes for KS since you sum on I. The same for labor. Income, it's the equation for income of a household, and the consumption, then the condition for the consumption, all the production in the economy is consumed by the household. And here again, a calibration for beta. And another point, in this part of the program, GAMS read line by line. Then you cannot, for example, here you see there is a alpha here. Here is if I put this equation before here, I will have a problem in the resolution, because when GAMS read this line, it see the alpha I, and we don't have assigned at this line a value for alpha. Then you will have an error at this point. It's why when you read the program, you have to be sure that everything you declare is assigned before the calcul, when you use this the one of the value. Okay, then here I have declared all my parameter, true parameter. I declare variables as parameter, it's the variables at the reference period. And I assign for each parameter a value. And I can assign with the matrix. I can assign value with the literature, and also with calculus done directly in the model. Je vais faire avec le alpha. Ici. And here I had a display for each of the parameter. Then display, I told before, it's the mean to see the value of the variable or parameter to verify that it's the good value. And it's also the mean to verify, because here it's a calculus, then I don't know the value, but it's a mean here. When I put in co here, I can verify the value of the income. Tuami told me to put in text. We see that it's a mean to make here. C'est pas là parce que je pense que okay, it's not. Now it's a mean to make a comment. Then you see the color change. Then everywhere between on text, off text is a comment. Then the program will only turn on the first line. If I turn here, and no red arrow, and I have a display ici, then I have the value, then alpha is calculated directly. I see here the value of alpha for agriculture and industry, and beta, and so on. And I can also verify the value that I put directly from the matrix here. See that WO is equal to 1 and rho is equal to 1. Then it's a mean to verify. For me to make an error, I can here, for example, I come back that if I run, I will have an error. That means symbol declared, but no value has been assigned because the alpha is calculate after the. I know here the error. It's easy, but sometimes it's not so easy. I know that alpha here has no value since I declare the value of alpha after the AI value. Then it's why I have an error in my program. Okay, I continue. Stop me if you have some question.
Yes, I have one, please. Can I ask it?
Yes.
So why? Sorry, I will take you to a little bit of the beginning. When we saw the model, I thought that like the capital, labor were all in volumes, like that was because in the equations we had like the quantity multiplied by the price. So capital is in volumes. Then when we are here in the program, you are transforming it, like you're supposing like it's in nominal, and then you're going to the real. So why did you do that? Wasn't it like already in volumes?
No, because the story is this, Asma, because when we are modeling, the data we have is coming from the sum, and in the sum, what we have is necessarily a value. That's the first part.
I get it.
The first part is only in value. So in a contability level, when we have accounting level, in the accounting level, I cannot, if you can see here, it's descend jusqu'à y égale. Ici, all this part is in value. This is a value. This is not a combination. This is not a production function here. This is only accounting things. After that, because we are in modeling we have not only the value. Principally, we have the volume. So we have to divide by the price. And after that, as Dorothy told you before, after that, we will have the variables coming a volume after that. And we can do what we want to do. In this level, we have a volume. Why? Because we divided by the capital. Okay, you see?
Here it was in value.
And
because I declare the value.
Yes. Now I see it perfectly.
By the price, now it's a volume. And here it's a volume. It's why I remultiply by the return of capital.
Because for alpha, for alpha, what you have here is the CPU condition that Dorothy introduced in the first part in this session, and what we have deduced yesterday. This is now a calibration of a parameter from the data, and the data in this to calculate alpha is from a value. So we have to multiply R by K and BX. Okay, so it's not clear in the first time you use for some of you that this is the story. The data is coming in value, and we have to convert value to volume. So we have to read price before. That's math.
Yes, thank you very much. That was very clear.
Elements.
Then now I have the situation for the reference period, and I begin the work on the model. And now I am on the second step in my figure that I present before the break. Then the keyword is variables. And here you see it's the same variables than here, okay, but without O, because now it's a real variables. It's the variables of the model. And we have the situation at the reference period, but the model will generate new variables after shock. I have one variable here that it's important also, and I didn't mention directly in the presentation of the model. It's the Léon variables. Léon is for Valras. It's the full name of Valras. And it's a mean to verify that we respect the Valras law. Then your model is right. Then we use this artifice in the model to verify that we don't have any error. And at the end, we have these variables would be equal to 0. Then it's a mean to verify that our model is normally okay. Like, then it's a mean to verify that the Valras law is verified in the model. And in each model, you will find this kind of variables, and the convention between models is to put the full name of Valras, that is Léon. Now we declare equation, and here it's in two parts. The first part is the declaration of the name of equation. Then you have to declare. At this point, previously I mentioned that GAMS read line by line. At this point, GAMS read a system. Then you can put an equation before another. After the declaration, you have to declare each equation here. Then you have a supply function, labor demand function, capital demand function, and so on, all the equation of the model. Then you see when we have two equations, you have an index I. I discussed about that before. And here you have the equation of the model. The specificity, then at this in this part, each equation, the GAMS read this part simultaneous. Then you can change the order of equation. There is no impact of the result. Before it was not the case, but in this part you can change without any problem. You have to declare the name of equation that you give, then it's the name supply I, you find supply I. After, you have to put 2 points. It's the convention, it's not the convention, it's the mean to give the information to GAMS that it's an equation that I declare. Now I will write the equation. And you have the equation here. Here, the equal is not only one equal, it's equal, E equal for equal. Then it's the mean to mention that you have an equality in the equation. And at the end, you have the semicolon here I mentioned previously. Then
equal to equal here is different from the one we had before. If you go up, we have equal here, where we are only between data we know. This are past. Here we are in the model, and in the model, the equations, when we are writing equation in GAMS, we have to use a syntax like this, equal, égal. Okay.
Then here you have all the equation of the model. Here, Léon appears, and you see it's the equality, it's the equilibrium on the labor market. Then we hope that Léon will be equal to 0 since we know that the sum of the labor demand should be equal to the labor supply. And normally, if the model is okay, is consistent, you will have Léon equal to 0. Then here you have the equation. After that, you have the initialization. Then here, the mean to initialize is to take the variables and put L for level and fixed. Then it's L is for endogenous variable and Fx for fixed is for exogenous variable. Then if you remember the presentation, we see that the three variables fixed in the model are the price of one good. Here it's agriculture, and the price of the agricultural sector is equal, is fixed. The demand, the supply labor, and the supply of capital here. Okay, here it's because we have a simulation, but I can make this one. There is nothing, then KS is equal to KSO, here multiplied by 1, and I can make a shock on the capital as I explained. And for the endogenous variable, I put dot L for level again to mention that this is the variables who variate in the model. And if I make a shock, this variable will change in the model. And it's a mean, and I give in the initialization, I give the initial value. And the initial value is the value that I declare consistent with the matrix and so on. Okay, and here it's a mean to make a simulation. Then here I multiply by 1, no simulation, but if I multiply by 1.15, is like I have an augmentation of an increase of capital of 14%. Okay, that's the mean to apply a simulation. Then here my model is ready. I have to give him a name. I call him simple, and I precise the equation that the model should consider to resolve the model. Here we have all, that means all the equation that I have here should be used to find the solution. And the keyword to solve the model is solved. And here I declare the name of the model and the characteristic of the model. Solve is to say to GAMS that I want that he solve the model simple using a solver here. And you have a different solver. You have solver. We have no time to go further with that, but you have different solver. Some maximize, optimize something, and others resolve a system of equation as this one. Then here with this solver, then solve the model simple using CNS, this solver. And here it's a command, execute and load. Previously, I mentioned that GAMS develop other routine to present results. Here it's one. You can now give the information, ask to GAMS to put the result in the GDX platform, and you have all the result in this. I will show you quickly. You can find all the result and take this result and export in the Excel to make other, or even in Stata or other software. Then it's GDX is an interface where you will find all the results of the model. You have also the possibility to, as Shahir did in the code, to calculate the variation, and to put here is the variation between the solution after simulation and the situation initial. And it's the variation in percentage multiplied by 100. You have the variation in percentage of the demand of capital for each sector. And you write, you declare the parameters, because you have to give this information to GAMS. I want to calculate something. You give a name to the something, and you calculate the variation for each variable that you have in the model. And you can display to see directly on the output of GAMS, but you can also save these results in the for Excel format, as you see here. Then with the keyword put, you told to GAMS to create a table that you can read directly in the Excel software. Then here you have different means to find the result. If I will make a small simulation, here and here, then here I make a simulation of increase of capital, and I have a solution. Here it's the GDX, and before that, here, when you run, you have a window like that, and you see that you have a solution. The system is square. We are happy for that. And you can find different results. And you have also the GDX file that is created. And you have also the result one, that is the Excel file that we create, and you can open with directly in the Excel, but here you see the result. Then, for example, here, here for the GDX, see if I have the situation of reference for consumption 4 and 6, and after simulation, we see that as I increase the capital, we have an increase of production, production. And as I have more production, I have more consumption, and it's why I have an increase for the consumption level for the two goods. Okay, more in industrial sector, not more in terms of variation. Je l'ai là, ici. Donc, I can show you here. But you see, I have the reference level here and the after simulation variable. If I look for the supply of capital, the initial value was 4, but the initial is the initial was 4. The value after simulation is 4 plus 15%. And if I look for LS, par contre, you see, it was 1, and no, LS. Here it was 6, and after simulation is still 6. I have no, it's an exogenous variable, then, and no shock on this variable. And finally, I will show you Léon. I hope that Léon is equal to 0, and it's the case. It's exposant minus this 10, but it's like a 0. Then my model is okay, is square. If I go to the output here, I can see the statistic. I have 13 equations, single equation, and I have 13 single and fixed variables. Then the number of variables equal to the number of equations. Then it's why I find a solution. I don't know, it's very quick, but I want to let some time to Shair for the open economy model. And do you have some question? No question? Then Shair?
Yes. So, any questions on what Dorothée presented before I continue? Okay. So, we have half an hour today, and perhaps I will start by introducing what we'll be doing for the open economy model. And then we continue next week, and we will have to shorten a bit the dynamic part, but that's not a problem. So basically, so far what we have seen with Dorothée and Tuhami, after the rationale of CGE models, the macro and micro tools that we need, and then how to build a CGE model based on the optimization that Dorothée showed, and that we have to consider the factor of production that we have, labor and capital, with the Cobb-Douglas production function, the households that will earn their income from labor and capital that will be spent on consumption. And at the end of the day, we have this equilibrium on the different markets, the factors market for capital, where capital supply is equal to capital demand, labor supply is equal to labor demand, and what we supply in terms of goods is equal to what we consume. That's why we have this Y that is equal to C. And very importantly also, as Dorothée showed, because this will be very useful for our open economy model, is the Léon variable. And the Léon variable is a key variable because this is the variable that reflects actually what Tuhami said yesterday in terms of the Léon, the Walras law. Because if we have n markets and n-1 markets are balanced or are in equilibrium, this means that this nth market will also be in equilibrium. So the reflection of that is that this additional variable that we add, Léon, should always be equal to 0. If it's not equal to 0, this means that we have a certain flow in the model that is not considered, or an expenditure that doesn't have a revenue, or a revenue that is not spent, and so on. Okay? The idea of what we do, of what we want to see now is what happens if we introduce the rest of the world, because introducing the rest of the world implies several things. The outline of what I will present, I will start with the rationale itself of what happens when we introduce the rest of the world in the analysis. What are the data that we need in order to consider the rest of the world? Then a fundamental thing that we'll probably cover in more details next week is the difference between the constant elasticity of transformation and the constant elasticity of substitution. What are the main blocks that we have in an open economy model? And then what are the other applications in general that we will not do in our case? And finally, we conclude with the model itself that we will calibrate in GAMS. Okay? So basically, the rationale of what we want to do is to model all that in our open economy model. So we assume first that we have a small open economy. Small open economy means that we have a price tag. So world prices are taken as exogenous, and this will be one of the assumptions that we will have. So all the world prices are exogenous. Jordan or Tunisia or Morocco or Egypt, they satisfy this condition because they receive the world prices as a variable that is imposed on them, right? So that's why they are all price takers. So we assume that we have a small open economy, and by small open economy, small, it's a price taker. Open implies two things. On the one hand, we have a flow of goods, exports and imports, and we have a flow of factors of production. So capital, which is FDI, and labor, which is migration, right? So as you can see here, in addition to the flows that Dorothée and Tuhami presented so far between the labor market, the capital market, and households, in addition to goods market, we're going to add an additional institution, which is the rest of the world. So the rest of the world will buy from our country the exports, or in other words, the country of interest is going to export those products to the rest of the world. The rest of the world will sell its products, so our own country will import, right? And the difference between them, if we assume that we have also transfers like remittances or any other transfers between different institutions, will constitute the current account. And the current account represents for us foreign savings. So that's what we have here in this graphical presentation. So at the end of the day, in a very simple open economy world, if we assume that we will not consider the migration part and the FDI, so we will assume just that our small open economy will trade in goods and services with the rest of the world, okay? So we have exports, imports, and foreign savings. Any questions so far? So how can we model that? This is a rather comprehensive model, even if what we will see in GAMS is simpler than that, but this is important to give you an idea of what we're aiming at, okay? So we start with the factor here, the factors of production. Just a second. So we have here the factors of production and the intermediate inputs. Both are combined together, right? They can be combined in a production function depending on the functional form that we assume. And Tuhami presented yesterday different functional forms. We can assume that factors of production and intermediate inputs are complementary. And in this case, we're going to have a Leontief production function. They can be substitutes in Cobb-Douglas or imperfect substitutes in a constant elasticity of substitution, depending on the elasticity of substitution that we assume. So we combine factors of production, which are labor and capital, with intermediate inputs, which will help us produce, right? Once we produce, our products will either be exported to the rest of the world or will be sold domestically, right? If they are sold to the rest of the world, they are exported. And if they are sold domestically, so their destination will be the domestic market. In general, if I export a certain good, it will not be an identical product to what I'm selling domestically. So let's say we have a producer of olive oil in Morocco, right? So the olive oil that is produced domestically perhaps will have a label that is written in Arabic. It will have a bottle that has a certain shape, and so on. But if Moroccan producers, they want to export this olive oil to the rest of the world, they will have to change the label, perhaps translate it into French if it will be exported into to France, or translated into English if it's exported to the UK. They will change the packaging. Perhaps the quality of oil can be higher given that it's a richer market. So at the end of the day, the difference between, we cannot say that the olive oil that is sold domestically is a perfect substitute to the oil that is sold abroad. In other words, domestic producers will have to transform this domestic product to make it exportable. Okay? This transformation between the domestic product and the exportable and the exported product to make it exportable, right, is what we call in economics a constant elasticity of transformation. That's why you can see here that between exports and domestic products, we have a constant elasticity of transformation. Okay? That's from the production side. And we will see the mathematical details of deriving a constant elasticity of transformation because this is very important to understand. But for now, I just want to introduce the concept itself. From the consumption side, we have a consumer who maximizes his or her utility, and this utility will be satisfied by domestic goods and imported goods. So my consumption basket will be constituted of imported goods and domestic goods. The same as a consumer, the imported good will not be identical to the domestic good. So they are imperfect substitutes. Perhaps as an Egyptian consumer, I will consume ready-made garments that are produced in Egypt, but I might also consume some ready-made garments coming from Vietnam, from Bangladesh, because they are different varieties, right? And if imports, they differ by their geographical origin, we call this the Armington function, okay? And the Armington function, the rationale behind is that in general, when we import goods, they will have some characteristics that make them different or differentiated, to be more accurate, based on their geographical origin. And this constitutes the Armington function that is a constant elasticity of substitution between the domestic goods and the imported goods. So in other words, we can have what we call, and this we'll see later, a nested level. So as the consumer, I will choose first whether I consume a domestic product or an imported product. If I decide to consume an imported product, I will decide whether to consume this product from Vietnam, from China, from France, from Italy, from Morocco, and so on. Okay? So we call this a constant elasticity of substitution. Mathematically speaking, so here we have the consumption that will be satisfied by either the domestic products or imports, and the mathematical relationship is the imperfect substitutability based on the Armington function that is a CES. Okay? Mathematically speaking, the constant elasticity of transformation and the constant elasticity of substitution, their derivation is very similar. One is convex, the other is concave, and we will see this next week. However, the point that I want to highlight is that both, they help us understand why domestic products and exports are not perfect substitutes, and why domestic products and imported products are not perfect substitutes. Okay? So here we have the constant elasticity of transformation, the constant elasticity of substitution. Then we have the difference between exports and imports that will give us the trade balance. Okay? And then this consumption will be consumed either by household, private consumption, by the government, which is the public government consumption in general. I mean, in national accounts terms, it will be the purchase of goods and services by the government, the investment made by the firm, and the intermediate inputs that are used by economic activities. So this gives us the different flows that we need in an open economy model, which are basically, we will need to model, mathematically speaking, we will need to model this CET function, the CES function, introduce the trade balance, and consequently, given that we have transfers, the current account, and foreign savings. Any questions so far? Any questions on the CET or CES before we continue?
Yes, I would ask something, if
Yes.
possible. Are you calling it consumption because we will have only one equation for it? Like, because when we call consumption, usually it's it's for households, and then for government, like you have government spending,
Yes.
and investment, you will have another equation for investment, and then
So,
you see.
Yeah, I got your point. So this is just here to simplify, but clearly in the model itself, we will have an equation. I mean, it will depend on what you want to do, because, for instance, I can assume that for the government demand, it's exogenous because it's a governmental decision. We will have a demand equation for households, that's private consumption. We will have an equation for the demand for investment by firms, and for the demand for intermediate inputs. In other words, if in more accurate terms, we can call this consumption the absorption, the domestic absorption, with so goods that will be absorbed on the domestic market.
Yes.
Any other questions? Okay, so what are the data that we need in this case compared to what Dorothée presented? We need basically trade flows, exports and imports, so they have to be introduced in the SAM. We need transfers to and between households and the rest of the world, like remittances, between the government and the rest of the world, like grants or aid, if we assume that the domestic country or the country in question gives some products to a flow of foreign aid to the rest of the world, then we have to introduce this as well. Perhaps also transfers of firms to the rest of the world or from the rest of the world, if we have any transferred profits or any flows between domestic firms and the rest of the world. So all this we need to take into consideration. And finally, depending on whether we have a surplus or a deficit, we will generate some foreign savings that might be positive or negative, and this will represent the current account. Okay? In a social accounting matrix framework, so if you remember what Tuhami said yesterday, is that in order to read the SAM, the column pays to the row, right? So if we are selling, if the domestic market is selling to the rest of the world our exports, because we are exporting, so we will send the goods and we will get the foreign currency instead, right? So it's the rest of the world that will pay to the market of commodities. For imports, it's the inverse, because it's the domestic market commodity that is going to pay to the rest of the world the price of imports in order to get the goods. So we have exports, we have imports, and then we have the set of transfers between the rest of the world and the domestic institutions. So here the rest of the world pays to household remittances, It can pay also to other institutions any kind of grants, aids, other transfers in general, and all this will constitute the account of the rest of the world. So the rest of the world will pay the price of exports, will pay inflows, will pay remittances, and will get the value of imports. The difference between them will give us here the foreign savings, and this will constitute the total account that we have. So here we're going, this will help us have a balance between what the rest of the world is spending and what the rest of the world is getting. Okay. Any questions on the idea of the matrix and the data that we need? Okay. So that's basically what I have just said. So the difference between foreign receipts and foreign receipts and spending is the amount of the rest of the world savings, which is equal to the inverse of the capital account. Well, we have less than 15 minutes to talk about CET and CES. I will perhaps start the rationale behind them, but the mathematical details, I will keep them for next week because I don't want to start them today and then stop without being able to finish the whole part. So, as I said, what is the idea of the supply of... Yes, Samira?
I just want to ask. Now we have introduced the idea of investment. So have we introduced in the equations the idea of saving by households in my country?
Yes, in the model that I will show you, you mean whether in the model I will show you will have an investment equation or not?
Yeah, I mean that before we were talking about that the income will go all of that to consumption. Now we should talk that a household's income goes to consumption and savings. So these things go to investments, but I can't see the reflection of that.
Yes. Actually, in the model I will show you, we will still assume that we don't have any savings, which means that all the income will be fully spent on consumption. But clearly, in real CGE models, we can introduce this investment we can introduce a consumption function where a fraction of the income will be consumed, the rest will be saved, and the savings will be allocated to the investment. But in the model that I will show you today, it's not the case. I just want to highlight perhaps the confusion comes from the fact that I said foreign savings. Is that the...
No, I got the idea that a foreign saving is transfers from abroad.
It's not only the transfers, it's the difference between the receipts. It's basically the current account.
Yeah.
So the current account is the summation of the trade balance and the net transfers, right?
Yeah, but the idea that there is now firms, we talk that these firms make investments, and we talk that there is foreign savings, but
yeah.
After all of that, we still say that there is no private savings.
Exactly. So far in the simple model that we will see next week, it does not include explicitly savings and investment. But at the end of the course, especially in the dynamic part, before presenting the microsimulation, we will see an example of a real model and how we have an investment equation and a savings equation.
Okay.
Okay, but so far, I'm just introducing the rest of the world without assuming that the households save and therefore we are able to invest.
Okay, thank you.
Any other question?
For me, thank you. No, thank you.
Okay, any other question? Okay. So, as I said, we are interested first in the supply of exports and in the demand for imports. Clearly, we cannot assume that they are identical, as I said, because exports or exportable products are different from domestic products. either in terms of quality, in terms of variety, in terms of packaging, in terms of labeling. All this will make the goods that we sell to the rest of the world are slightly different or differentiated compared to the domestic products. So that's why we want to analyze the behavior of the producer and the behavior of the consumer when it comes to imports. And for this, there are two important aspects that must be considered. On the one hand, we have to see how the composite output translates into the supply of products, because I'm producing an output. Part of it will be sold domestically and part of it will be sold abroad. And then how the supply of each product will go to the destination market itself. So in mathematical term, that's what we call that the product are transformable, which means that they are not identical, they are not basically identical, okay? And that's the rationale of the constant elasticity of transformation. So like in economics in general, the constant elasticity of transformation, we assume that the elasticity with which the domestic products are transformable into exported products, this elasticity is constant. Okay, it does not change. It's not a varying elasticity. So we have a constant elasticity of transformation. Constant elasticity because this rate of change is not varying. It's a constant elasticity of transformation because we transform the domestic goods into exported goods. Symmetrically, for the demand for imports, the buyer behavior is symmetric in the sense that we're going to assume that the consumer, once he has access to different goods, he will have to substitute between domestic goods and foreign goods, and they are not identical. So we're going to have a constant elasticity of substitution. So the elasticity again is still constant, but I'm substituting from the consumer perspective between domestic goods and imported goods. And in general, when we consider both the constant elasticity of transformation between exports and domestic goods, and the constant elasticity of substitution between domestic goods and imports, it really reflects the dynamics of trade in the real world. Okay. Given that I still have a few minutes, I will just show you the mathematical form, right? Perhaps you will not understand all the technical details of that, but I will present next week how we can achieve this this mathematical formulation. So here you can see that we have from the export side, XS is the total supply that we have of coming from the activity J. This will be allocated between what we export and what goes to the domestic market. So EX is what is exported, D is what is sold on the domestic market, again of J. Okay. What is the share of what I export? It's beta. And what is the share that goes to domestic market? It's 1 minus beta. Okay. However, so far I didn't talk about any elasticity of transformation. I'm just talking about exports and domestic goods, the share of what goes to the domestic market and the share of what is exported. So now I have to introduce the elasticity of transformation, which is measured by here kappa. Okay, so here this kappa, as we will see later, is what measures the transformability of exports and domestic products. Here we have a scale parameter. This is minor. I will keep it for now. We will not analyze it. It's like the A that we have in the Cobb-Douglas, more or less. But what is important now, and what we will see next week, is how to interpret this kappa, how to derive the whole equation, and how we can derive the demand for exports as a function of its price. Okay? For the CES, it will be identical to this one with two differences. Instead of having here the total of what I produce, I will have the total of what I consume, that we will call Q. The B will be A. The EX will become imports, and the D will remain as it is. And we're going to have, instead of having a constant elasticity of transformation, we will have a constant elasticity of substitution. Okay? So I will not present the mathematical details today. I will present them next week because I want to do the whole thing one shot. But before we conclude today's session, do we have any question, comments, or concerns, suggestions? Anything that's not clear, given that we just have 2 minutes? Okay, so if we don't have more questions, just to recap what we have done during these 2 days. So we started yesterday with the relevance of CGE models, what they can do, what they cannot do, their rationale, how we can build a CGE model based on macro and micro tools. Then we started today with Dorothée, the simple model of a closed economy. So there is no trade. How what is produced based on capital and labor is consumed by household, no savings. We have an equilibrium on all the markets, goods market, capital market, and labor market. What guarantees this equilibrium is the Léon variable, right? That makes sure that all the flows are considered in the model. We have seen on GAMS you received the code today, the simple model. So in order to prepare for next week, please go through the notes that were shared by Dorothée and the code also. Try to run your own simulations. In general, when we have a shock, we can simulate exogenous variable, capital supply, labor supply, the exogenous price. Play with this model. Try to interpret the results, because this will help us next week, before we start the open economy model and the rest of the derivation, make a simple exercise on how to interpret the results of simulations. And also if you have any questions. So any questions, anything that's not clear?
Yes, I want to ask one question.
Yes.
Just now you said, like, to produce a shock, we had to do it on the exogenous variables.
Or the parameters, either parameters or exogenous variables.
Okay, so not the endogenous variables.
No, you can't, because they will be determined by the model.
Yes. Can I use this, like, to choose my closure variables?
Okay. But at the same time, I'm choosing the closure will depend on 3 things. They will depend on first the characteristics of the economy, will depend on the literature, and will depend on what you want to do. So, for instance, if I have if I assume that if I want to simulate, for instance, a real exchange rate shock, in this case, the exchange rate will have to be constant, and the current account will have to be endogenous. So that's why. But if, for instance, the exchange rate does not matter for me, but I observe that over time the share of current account to GDP is constant, then in this case I will let the exchange rate adjust and the current account will be fixed. So that's why I have to make sure that the assumptions I'm making are relevant to the economy, are that they do not contradict the literature in general, and they are in line with what I want to do.
Thank you very much.
Other questions? Anything that's not clear? Okay, so Dorothée and Tuhemi, would you like to add something?
No,
No.
thank you.
Thank
See
you.
you next week, inshallah.
Okay, so we end today's session and we will meet next week, same time, same days. And if you have any questions, you have our emails, don't hesitate. Thank you so much and see you next week.
Thank
Bye-bye.
you. Thank you.